All right. Oop. There we go. A little shot of my room there. Welcome back to another week. Thanks for joining me. We're going to be working on. We're just going to keep working on our Asteroids clone in Haskell that we wrote, or we've been writing for a little while now. We're getting close. This is what the game looks like at the moment. If we run it. All right, we just added the moving asteroid motion, and we have like bullets firing. And we got a pretty up things, but we got motion going there. And that's what we got so far. So then, basically, I think I'm going to do a little refactoring maybe tonight. We'll look at how we can kind of like abstract out some of the 2D physics for our game objects in Haskell. And if we have time, we'll get into maybe collision detection for this game. Whee! Okay. So that's that. Let's bring up our project. Okay. So the reason why I kind of want to go through and do a little bit of refactoring is because we have like 3 different kinds of objects in the game at the moment. Maybe we might do, if we do power-ups, that'll be like maybe 4 kinds of objects in the game that can all do like the same kind of physics, but they're all implemented individually, like over and over again in kind of the same-ish way. Which, for a game that end this size, isn't too bad. Like, it's your game, right? So if you're making your own game at home and whatever, you know, does the game work and is it fun is the goal, not did I write the code the right way or whatever that means. So we shouldn't really worry ourselves too much about that. But I feel like we can get a little bit of benefit out of this just because like this is mainly a learning project for one, and I like showing refactoring in Haskell. And 2, we might make the code just easier to like maintain and modify if we want to add new object types and things like that. And who knows? Don't like over genericize everything and try to make everything into a framework right away. Sometimes just write the code. It's messy, whatever. Just be consistent. But if you do get to that point where you've seen yourself repeat something like 3 or 4 times, and you want to do this kind of like refactoring, then it can benefit you down the road because you might be able to extract that out into a library and then you can reuse that in future games, right? So there's one reason why you might want to push that lever and do like a refactoring that we're about to do now, I guess. So I think the way I'm going to go about this is that I'm going to go with something like something called the has class pattern. And we're going to see that hopefully in a moment. The basic physics pattern that we have here is that each thing that we want to move, like an asteroid or the ship, well, that's just in the game state stuff, but like it has a position, a size, rotation. It has a couple of vectors for the acceleration, velocity, that kind of thing. And the formula, the equation that we use to move something in our space, in our game, is all repeated. But we've again written the same thing kind of over and over again. So like when we update the bullet physics, right, we call this update bullet function, which takes the position, does this formula here, bullet position plus bullet velocity multiplied by the time delta of this frame, this physics frame, and like integrates them, right, into a new position, wrapping it around on the torus, so it goes around the screen. Similarly with the asteroids, we have an update asteroid function, and here again we see the same formula again, just specific to the asteroid. Its position, its velocity, the time delta. All right. And then we like get that position back and we kind of update the code and add it to the new position for this next state of the asteroid. All right. And the ship we did earlier on in the process, but I don't think it's terribly different, except that we didn't write a particular record for the ship. It just gets it out of the game state, because it seemed probably like the great place at the right time, a great place at the right time, great place at the right time, right place at the right time, something, whatever, you know what I mean? You know what I'm saying, Jim? And, yeah, so we just update the ship. Where did that code go? I think we just, or maybe we just updated here. Am I getting this scroll lock thing again? Okay. Sorry. I think it's a keyboard thing, and I just pressed a function key that, which Emacs seems to listen to. Anywho, since we're updating in the game state, I think the player ship code that we update the thrust and turn amount, we do that there. The formula, yeah, so the position formula is still the same here. Now, there's some other things we calculate for the ship as well, like velocity and whatnot. So if we were going to do this refactor, we would need a way to kind of not talk about any particular object or any particular type, right? And we'd need a way that to still get the position of that thing, the value of that type, the velocity, and you'd have to give us a time delta. But then we could replace all occurrences of this formula with our more with our generic function. So, like, again, this is such a small game. This is not going to be a huge... I don't expect there's going to be a huge difference. But a game with a lot more objects, it could be for sure. So let's check this out. Let's see if this is going to give us a win. I'm going to do this on a branch locally. So like physics refactor. So for a lot of these things, we're wrapping on the torus. Just kind of this extra function on the position that kind of just changes a little thing about the position on the screen. So I'm wondering if this function should take in a value of this type. All right, and we can make it understand like the position field on that thing and the rotation. Well, maybe we'll deal with the rotation separately. But we return it with its position field updated. I wonder if we can manage that somehow. So a typical has class pattern. What does that look like? And will it suit this code? Okay, let's go say just above bullet. After game state, sure, why not? We'll start a class. We'll call it has position. Okay. And has position of A. And then we'll call our function in this class position. All right, this will be like a getter. So we do get position. All right, this is only one way of doing this, by the way. There's lots of other ways we could be doing this. We'll call this get position, and then position should be like a v2 float, right? That's how we define it. Let's also have a set position so we can update the thing. Or, no, let's flip the arguments around on that. V2 float. And we give a new A. Yeah. All right, now we can implement an instance of this for our bullet. Or, sorry, instance has position bullet. Where then we can define get position and all that sort of stuff. Right? Get position is just going to be the bullet position function. And set position is going to be a bullet, a P, and it's going to be bullet where the bullet position equals P. All right, that's it. Not a huge deal, right? Hopefully. So if we have like a bullet, let's just instantiate one. So like 20 and 10, and a v2, whatever, 1 and 1, and oh, let's try that again. And a bullet tick 0, say. We have this now. We have this nice kind of function, just get position of B. Because we wrote the instance for bullet. Now we have this kind of function just called get position. It's not get. It's not bullet position. It's just get position. Similarly, if we want to set position on B, we can give it a new v2. We can do like 23 and 111. And then we get a new bullet back with those with the new position. All right. Okay. Similarly, we also need a class for the other field, velocity, right? For our calculation. Which is also a v2 of floats. And we'll do set position as well. Now this is already like looking to me like to be, you might be like, well, this is quite a bit of work. Yeah, a bit of typing. It's fairly mechanical. But this kind of like idea of getters and setters is, now don't quote me on this, I don't know the whole story of how lenses came to be. You'd have to ask Ed Commett for that. And maybe some of his co-conspirators. But this is a very, such a common pattern that you can, there's library, like lenses kind of abstract this sort of thing out. So if we were writing this with lenses, we could probably even do away with these has classes entirely. But we're just learning, you know, we're learning about different patterns and different approaches and that sort of thing. This is one way you can solve these sorts of things. All right, so now we can do instance as velocity. Velocity and set position. Where the bullet velocity equals v. All right, so you can see even this, if we implement this a few times for a few different types, like they're almost all very similar. So that's a sign that you can, there's probably some higher level type of construct you can use to even get rid of that boilerplate if that becomes a problem for your code. But we're not gonna cover that right now. We're gonna keep going on with this. And so the idea now that we have this get position, set position stuff, right? We can have a more generic kind of update physics function. Update position. All right, you give me, I think we store it as a float, the delta time. And we can put the, class constraints on here. Has position A. And has velocity. Okay. All right, class constraints. And then we can give a time delta, some A, a time delta, and I think it's in float. And then we get back a new A with the position changed. I guess, because that's kind of what the function says it's supposed to do anyway. At least we know that it can only access the position and everything and the velocity and everything, so it's not going to touch anything else about it either. Also kind of another hint in documentation you get from reading the types in this kind of pattern. So you get has position, has velocity, and now we can kind of do this somewhat generically. Right? We get our object, call it object, and we get our delta. We can call it dt, like delta time for short, because that'll shadow if I call it delta. And we can go grab our update bullet physics formula or equation. We can abstract out the bullet specific things here, right? Right, we can get position of object. Get velocity of object times the delta time. And then we can set the object and the new position. Now, our game is using this Raptorus thing for a couple of these objects. I think we should also take that into consideration with our work here for this update position thing. We can apply this Raptorus universally. All objects in our game wrap on it. The ship, the bullets, the asteroids. Probably fine. What's this 10 here again? Was, oh, the size of the border to wrap. Not very intuitive. I should probably document that. Wrap an object position around the edges of the screen. Syntax for literal code. I think it's... Can't remember exactly. I'd have to look that up. Size is the boundary over the edge. Right? Yeah. So, let's see. How often do we use a different size here? So, bullet physics uses 10. Update asteroid uses 10. We use a more dynamic size here, the game state player size value for it. So we could, for our kind of more generic update physics function, update position function, we could pass that in as a function as well, as a function argument. So if you want to do any kind of modification outside of what we're doing in here, you can pass that in, and we'll do that on the final. We'll give you that function, the calculated new position, and then you can return the final position. I think that might work. Although most of the time you might not want to. It might be the same. You could also handle this in a different function entirely. We can update wrap torus to take the object too, now that we have this kind of more generic interface. So I'm going to leave it in there hard-coded as position 10, and we'll try and keep a note to get to that. So I'll just write that down in my to-do list. Wrap torus. Okay, noted. Okay, so we got update position. Now all set. We should be able now to replace the update bullet physics with our update position code. So update bullet even becomes just... we can get rid of update bullet entirely. We'd have to flip the arguments a little bit on update position. And so that we can give the float, the delta first as an argument. And then it works on bullet. Although this code is a little bit, I might just actually write it out longhand. Just so we can write it out like that. No need to get fancy. Okay, and then our game so far should work just the same as before. Okay, no change in behavior. That's kind of the essence of refactoring, right? We're not here changing behavior, we're just moving code around. So at every step when our build goes green again, we should be able to run our program again, run our tests again, and everything remain the same. So I'm just going to keep our build kind of going in the background. Oh, actually, we didn't recompile. So let's just make sure we're actually compiling. I don't see any errors in my buffer, so I think it will. But oh, haha, I was wrong. So multiple declarations of set position. Oh. Velocity. Make sure to do that again. Velocity. There we go. Sorry, my bad. This is why I should have been running the build in the background. I don't know why I didn't notice it in the thing there. Okay. Let's get our type errors going here. Oh, right. We needed to do the Raptor's position 10. So I'm going to do that here. And just get rid of that. Oh, yeah, we actually do need that pattern. Because that's a deck, not an individual bullet. So we'll flip the arguments here. That code is a little bit clever looking. I don't know. I kind of like this pattern because it's just nice and concise, but the other way to do it is just use flip. Flip to kind of does the same thing. But unless you configure your lint differently, it's Haskell HLint is going to recommend that pattern anyway. And I just don't argue with the linter. Okay, and let's see. Some unnecessary parentheses. Okay, some warnings, got rid of those. Yeah, oh, some leftover pseudo-random stuff that I'm trying to get rid of. Okay, maybe I got rid of that one a little bit too early. Okay, there we go. Compiling, build, should be the same. Yeah. Woohoo. Super good. All right, so this is kind of one path you can get to a more generic physics library, right? This kind of has thing. And so for the different things that we care about, we're doing our positioning stuff. We can have this kind of generic update position function. It doesn't care what the type is, like A, as long as I can get at the velocity and the position. Right, and then those classes mean that I can get velocity, I can set velocity, or I can get position, set position. So we can keep doing the same thing for our other types, and just keep going. So let's do it for asteroid. Has position for asteroid where and one of the nice things about just being consistent with your naming and your patterns and how you structure code is that when you do these sorts of refactors, it makes it fairly mechanical and almost boring and just peaceful and zen-like. And that can be really nice because then you don't have to think too hard. So if you want to work on something that brings some value, but you're just a little bit, you know, for the day, don't want to think too hard, just do some refactoring. Okay, set position is going to be the same thing. Get our asteroid and our P. Do asteroid where asteroid position equals P. Get velocity. Equals to asteroid where the asteroid velocity equals V. And one kind of we might not get into it tonight, but another kind of neat thing you can do with Has classes is that we can implement these for containers as well for each of these types. So if we wanted to have, for instance, an instance of Has position A for like a maybe A, we can implement this class as well. Right, just object. Maybe. We might not be able to implement for this one, because, right? Because, like, what do we do for the nothing case? Right, this pattern isn't exhaustive, right? So we try to do nothing. But we might be able to do it for collections. Like list of A. Can we write that? I think we might be able to do the maybe one. Anyways. So set position would be setting all of them in this case. I'm sorry, set position x of p. Something like that. That's not going to compile, but that's the general gist of it. We can do stuff like that as well. So then when we have collections of things that have positions and velocities, we can work over them as well, just as easily. Okay, so continuing on. So we has position for and velocity for asteroids now, and now updating asteroids is also similar to how we did a little similar to how we did bullets, except we are also changing the asteroid rotation here. So we can do we can get rid of this. Oh, we can take the A like this. Asteroid by delta. And then we update asteroid. And we can get rid of this one here. And just update the rotation. That's kind of a recursive definition. It should be using A. That's a bug. There we go. All right, so it just kind of, at least in this case, like it's kind of a small example, but it just removed one line from our update syntax here. We could do it similarly for rotations as well in a separate pass. So that's asteroids and bullets taken care of. Those are two things that move. Okay. And we'll have to look at maybe doing something for the player ship. Now, some of the drawbacks of this, especially when it comes to like, this is a very small game, but like maybe a bigger game if you're trying something a little bit more ambitious. Right, is that with this type class approach here for has position, it has velocity and stuff. These more generic get position and set position functions are kind of taking this dictionary kind of as an argument, as a implicit argument. The dictionary contains references to these functions. So when you call get velocity, like in our more generic update position code, this get position here knows that about the function how to get it through that dictionary. That comes tied with the value here. So there's a slight overhead to this approach. Like it's not free. For a game like this size, I don't see it really mattering all that much. But it's there. It's not a huge overhead, but it's there. Okay, so ship. So in order to do this for the player ship, we would actually have to pull this out, the player ship, out into its own type. So we can write instances for it. Right now, the player ship's variables are all in the game state, just mixed in with everything else. All right. So I'm going to pause here for a commit. Yeah, and then we'll do the ship as a separate commit. So that when applied this change, we'll add has position and has velocity classes. These are used to refactor position update logic. into a generic update position function, abstracting out the update equation based on position and velocity. The asteroid and bullet types first to get instances and refactor their update logic using the more generic code. Cool. And let's look at the player ship. Okay, so first, I guess we're going to have to pull out all of the ship data into a record. Let's do that here. Data ship. This one's going to be a bigger refactor because these are all kind of all over the place. Hopefully a little bit localized. So as we make these changes, of course, our code's going to stop compiling for a bit. And that always makes me nervous. Which is good, because then you want to rush back towards compiling again. Quickly as you can. So I'm going to pop all these game state player blah blah blahs. And this, again, consistency is so nice. So I can just pull those out. And just plunk them over here. Not always consistent, but when I am, I am. That's a joke. Okay, so then we replace all of those fields in the game state with the player ship. All right, and then we're going to get a type error for constructing the game state. All this stuff. It's going to become game state player ship. It'll become init player ship. Actually, I'm going to put that whole block, just align that stuff up there. So I have to define init player ship. Let's keep it near in the init code. Let init player ship equal to ship with those values that we copied from earlier. Wants me to, I guess, okay, whatever, we'll go like that. And boom. Okay, then I think it's a lot of the game state update stuff. What's the problem here? See, missed consistency there. I didn't put the player state, all of the variables in the initialization next to each other. Well, that fixes that. Okay, next. Okay, so it's all the update stuff. Okay, now that we're not updating acceleration in the game state itself, we have to change the player's ship. You know what? Actually, let me go back to where we did the initialization stuff. These fields are also all wrong, aren't they? Unless we define them this way. They really shouldn't be named this anymore. Let's change that copy pasta. Like that, and let's call it ship. Yeah, we changed the type. We named the type with the copy pasta fields. Just fix those. There we go. Okay. Not super feeling this refactor for this player ship because now we're gonna have like nested stuff, but let's keep rolling. Charging forward. So ship acceleration. Game state player ship. Let's pull this over to the left a little bit. Okay. Aha. So, position we know how to update. We're going to ignore this player size thing and hope that our value of hard-coded value of 10 is going to be good enough. So the ship we should pull out. Or define. The ship's next state. So we can do update position of the ship by the delta amount. And then this will become game state ship, player ship, equal to ship where all these fields are going to be inside that, but changed up a little bit. Get rid of that. That. Ship. Okay, and then what else do we got? Okay, we'll fix those in a second. And ship velocity, game state player max velocity. That's going to be ship Max velocity of ship. That's all of those fixed. And these two here. Actually, if I move this ship update up here, actually could probably use some record update syntax to get rid of that. And then I can get rid of this. Get rid of this. Okay, those are all good. But we need it more up here. There's some more of these names up here. Okay, we can get rid of position. Leave acceleration and velocity at the moment. We'll be able to refactor some of those out too using our more generic code, which will be nice. So we can give other objects thrust and acceleration and that sort of thing if they want. Could be useful for the asteroids. Like when they explode. So all of these values, like velocity, use down here, acceleration down here when we construct the ship back up. So these are all prior state values. The values we get from this record update are going to be the update one with the updated position. This doesn't make sense actually. That should not be. Game state player ship. I want to make sure we're doing this right. Let's check our diff here. Okay, so yes, when I was rushing through this, this position value is calculated using the prior states position and velocity, which the line we added when we do update position is going to do. Okay, so if I move this up, That didn't quite work. Let me just cut that there, put that there. I think we should be able to replace all of these instances with ship. And that will mean the same thing. Let's just check if I'm right here. Okay, we're still moving, we're still updating. Yep, okay, behavior is just as before. Okay, good, good, good. Cool. We're not back into compiling it though. So rendering the ship now. We can simplify this code. Just to take the game state player ship directly, which will have all those values that we need. Dilly dandly in it. That'll be ship position, ship rotation, and ship size. So we're not quite there yet. So yeah, now the ship needs an instance of has position, which we know how to implement. Move a little set position. Not double, no, that's a typo. Let's set it. Ship P ship where ship position equals P and velocity. Ship the ship where ship velocity is equal to the. There we go. And we're back to compiling again, and behavior should be the same. I mean, we might have messed up. It's possible we still might have messed up the. Yeah, the movement code got skirborked in that refactor. So we didn't do that right. Oh, does anybody use ship position? Fire bullet. Okay, so fire bullet is using the newly calculated the next state ship position value. It's not quite what we want. Hmm. Nobody else is using it. So for only firing bullets, it should be working weirdly. But my rotation's borked, my acceleration is borked. Okay, so we got to go back a little bit here. Let's go. This hunk here. Yeah, we'll just undo this hunk here and try again. The render stuff should be fine. We can leave that. Okay. Okay, so let's get back to piling again, but let's try and we're gonna have to just pay a little extra attention to how we're doing things here. Okay, so I'm thinking one step we can take here is just wrapping all of these up in our ship record, and this here too. Changing nothing else. We'll just go into smaller steps here. Let's do game state player ship. It's a new ship. Bring all those fields inside. Yeah. These will be ship. Okay, this one's gonna, this type error here is gonna be, I think, the same solution we had as before. Just got caught in the crossfire. Game state player ship equals game state player ship, where the acceleration is that. Bring this over a little bit. That will be game state player acceleration, so that'll be ship acceleration. Okay. Now these errors down here. Well, getting the AX and AY out of this player acceleration vector now is just coming from the game state player ship. So ship acceleration game state player ship. Okay. Key down, button state. So we want to calculating the turn amount guarded by the key down state. If the button state left is pressed, we want to make it the negative rotation speed. This value is coming from the player's ship, so we can just use the accessor function for that. And we'll do the same thing here, it's just positive. Okay, that should compile. Well, at least that error should go away. Next. So we're calculating the thrust value here, and this is all both, these are both coming from the ship. Same with that. Ship thrust max. In the game state player ship. That probably has to get wrapped up. Okay, next one. Boom. Fairly mechanical stuff. Yep, we'll do that here too. Ship position of the game state player ship. Ship velocity of the game state player ship. Hey, Swarm Collective, how's it going? I am having a pretty good day. Pretty good day. We're just learning about, we're doing another refactoring. So we're learning about has classes and kind of making the physics a little bit more generic. And how to be careful during a refactoring. And so I did this once, had to throw out the work and try it again. And we're just going line by line, trying to maintain the same meaning throughout the rest of all of our equations before we apply the refactoring we want to do. So this will be ship velocity of the game state player ship. Something froze up. Ship velocity. Oh, Windows barfed on me. Awesome. Cool. Windows problems. Gotta love it. Gotta love it. Turn this off. Turn it back on. Okay, there we go. So the ship velocity of the game state player ship. So tell me, Swarm Collective, how are things going? How's your project going? I hope it's going well and you're enjoying yourself. So fire bullet here takes the ship position from the prior frame. Same with rotation. Awesome. These are going to have to be wrapped up in parentheses. Oops. Okay, almost done. One more. Do it like this. Nah. Okay. Almost there. Ship rotation. Oh, this is a function. That's also a function. Ah. Well, feel free to give your eyes a break and zone out a little bit if you need to. But thank you for joining me. Let's see. We have some fields of ship that are not initialized that we need. Thanks for the follow, the man. Apok? The Manopok? Much appreciated. Made a great decision today. Okay. So we have some. It's not technically the warning, but we should still do it. Which ones are we missing? Which ones? Ship size, ship rotation speed, thrust, max speed, that kind of thing. Right. Okay. That's going to be fine. As long as this is the only thing that's a problem, I'm okay with this, because we can actually replace this with game state player ship. We're using record update syntax here. That should be fine. Okay, so we're back to green again. We're good. Back to compiling. You always want to get back to compiling as quick as possible, right? And test these things out and make sure they're doing things. So maybe I started this up before it finished linking and building because it's still not working. And I expected it to this time because we were super careful. Okay, no, we're still getting stuck. No! No. Something else might be happening. Something else might be happening. That might be happening. The Mano book. Yes, there are not a whole lot, but if you do want to follow more people, you can find them. The link above goes to declarative.tv. It's a website that lists a lot of people who also stream Haskell, but also other cool programming languages as well that are kind of like outside the mainstream. And we also have links to our Discord there. So if you want to join in, follow along with the in-between stream chats, talk about your project, whatever, check it out. Yeah. So when I originally wrote this code, I was thinking about each next state value building from the prior state. Right, so the turn amount is calculating the next turn amount using the prior values from the last state. What we've tried to do with this refactor here is create a record for the player ship values and move it into a ship record so that we can give it a type, which means we can give it an instance of our has velocity and has position classes, so we can use the more generic physics update code for on the player ship. Because when I originally started designing this, it was kind of like I mixed up all those variables into the game state for the player ship stuff, which all this code was using, which was fine. It's fine code. It was okay code. It wasn't. It was what it was. But now it looks, yeah, something else is going on here, where it's getting a little bit. It's doing a little bit of updating. Like when I hold down the right key, the logical right key, physically as D, it's doing kind of a turn, but it's not going anywhere. But then it's reverting back to these original values. It's just like maybe the original values. If I hold the thrust, it's not doing anything here. If I hold back, it's not doing anything. If I shoot, it's shooting. Now it's constantly shooting. It's never setting the key back. So something funky is going on with my update logic here. And this is probably a good time to, hopefully with this refactor, clean it up a bit. But what else could be happening? Could we actually be updating the ship, but maybe not rendering it properly? Swarm Collective asks, where is the game state being updated with the updated game state player ship after the latest values are being calculated? Right? So the next state that we're building is up here. Right? And the player ship, the next player ship. So this is the player ship from the last frame, updated with the position values that we calculated, the ship rotation value that we calculated. So this one takes this position value from up here, which is calculated from the ship position at the last frame, plus the velocity in the last frame times the delta. And if we look at the diff in Git, we can see that hopefully that the meaning of that hasn't changed. We've just moved values around. So yeah, the last, before the change, it was this line here. Game state player position. So that'd be like the last frame's game state plus the velocity plus the delta. Right, so the difference between the two shouldn't be different. Should be the same there. Sorry, finger slip. There we go. That's good. Let's see, velocity, same thing. All right, so where we were previously using game state player ship, game state player ship velocity, we kind of transform it to just ship velocity of the game state player ship. So hopefully that isn't different. So what I'm thinking is we're actually updating the state properly, but maybe something about rendering is not quite right. Or maybe we're not. Let's get some debugging going on. Okay. Let's try, so rotation. Now it's super noisy to do debug statements this way in the update loop, but let's try and see if we're actually rotating. I'm gonna do a little debug.trace here. So let's show the game states player ship. And we'll get the ship rotation. Oh, this is pure. This might be pure code, so I'll be able to do it there. Oh, and I also have. I don't use post. I use pre. Yeah, that debug trace doesn't work there. Let's cut you out. And we'll just do it once per physics loop, because we recur on every more physics frames than we do actual rendered frames. So let's put that there. Oh, you need a value, of course. Next state. What am I doing here? Game state to ship. That's not right. What's going on there? I want to get, the next state should be a game state. It's not bound to anything else. So the type of that should be state. Yeah. So the game state player ship of next state. Let's just get that then. Oh, shoot. That's right. Record wildcard syntax. Well, kind of one of the drawbacks of using it. It's somewhat convenient, but it shadows the locally bound names of the record fields. So this is no longer like a function in scope here, which I was hoping it would be. Am I on GHC 9.2? Because if I am, then can use dot syntax. If I have the right extension. I don't think I am. No, I can't remember the name of this. Okay, that's a pain. It's always been a pain in the butt with using that stuff. Okay, so let's just show next state. Come on. Okay, I'm holding down some buttons. That's too hard to read. Let's go up to where we have IO so that we can pause that. Okay, so let's get rid of that there. We'll go to our loop. We have IO here, so debug trace is going to be a little bit nicer. We can also insert a cheap hacky way to insert a break here. Which we can do here. Actually, I wonder if this is the bug. And I'm seeing it. No, I don't think it is. It could be, though. Yeah, so we could do here. And when we get here, when game state ticks is greater than, I don't know, 300, and then we will do this thing where we will just grab, we'll just put strlen game state or state prime, and we'll ask for input. All right, so after a certain number of ticks, we're just going to get the line. and then print out some stuff. So then I'm going to just hold this down. Oh, sorry, I didn't rebuild. I broke. Yeah, and we're just pure box. That has to be the last thing. It has to be a valid action, and there you go. Okay. I don't have when in here. We do have unless. So we'll flip that around. We can't put that Sterling in that because we got to show it. What's print? Print is another one. It's kind of like same thing. So we go that. There we go. All right. I'll hold that down. Hopefully we get to our condition at some point, and we print out our state. Okay, maybe 300 was too much. Okay. Let's then... What's another approach I could do here? Oops, I didn't mean to get rid of Q pressed. Okay, another way we can do this is I could just take out this for a quick sec. If I'm right, if I have a hunch this might be the problem. If we just take that ship acceleration off, the ship will still work. The acceleration off won't work. Okay, it wasn't the issue. Or I just started that before I finished the build. Okay, yeah, just better. That is the problem. Okay. Just means that we're like, our acceleration is going to go off the map. We can just keep accelerating off into infinity when we let go of our key. So like our acceleration is really high right now, which is why it's taking so long for the ship to adjust. Which is why we need to reset it back to 0. Okay, so that was the line we got wrong. The original was this. It just set the game state player acceleration and nothing else. In the loop state prime. That variable has moved into the ship record. So we need to, the equivalent formula or the equivalent equation here is not the game state prime of the game state player ship. Oh, okay, yeah. I think I see the bug now. Do you see it? I'll give you a second. Stream lag. Yeah, you were right. this here, because of record wildcard syntax, is the game state player ship from the last frame. That's being updated there. So, how do we fix this? Well, one is the ship from the state prime prime. Yeah, not using state prime prime to get the updated game state player ship. Yeah. Exactly. So, that's a simple fix. Hopefully. It should be. Let's get rid of put that back in. So we are, yes, we are using the record update syntax here, which is very unfortunate. As we saw, oof, that's so frustrating. Let me write a quick little function to try and get around it. Just call it get foo. We get a game state and return the ship. And so game state player ship in this case should actually be get foo of state prime prime, where the ship acceleration is reset. Is there a good way around that? There we go, we're back. Even our hard-coded value of 10 for the torus wrapping around the border seems to work just fine. So we might not need the dynamic thing unless we want to like increase or decrease the player size when we teleport them across the screen for the torus wrapping. But anyways, cool. So that works and is fixed. Except for this get foo thing, we can't leave that in. So that's kind of the issue and the kind of drawback of using record update syntax. Or record wildcards, I should say. Is that game state player ship is no longer a function in this scope, it's a variable. And so getting the game state player ship out of this state prime prime, we need to use this get foo function to get around the name shadowing that's happening there. Blah, gross. Let's see if we are using... So maybe record dot can save us if I'm using the right version of GHC on this project. Record dot syntax is a pretty new addition to Haskell. Overloaded record dot. So it provides this kind of familiar dot syntax you might be used to from a lot of other languages, if you've programmed in other languages before. Where you can just do like c.name. And very handy for nested records. And look, wow, no lenses. Lenses are still useful, don't get me wrong. But for the simple cases where you might want to pull in lenses just to do this kind of stuff, without having to do like all the stuff we've been doing with kind of like record names and the generated functions that it builds for you and pulls into scope, you can just do it this way. It's only in 9.2 and up. So in order to figure that out, I got to go to my stack.yaml, look at resolver we're using. 1931. Go to stackage. 9.0.2. So I don't think we have it. If we update this stackage demo to it might save me. But no, let's pretend we just don't have it. Well, I could be happy with this as like a where thing. Is there a way to get around this Swarm Collective? We call it get ship. At least it's kind of like this local, it's localized the nastiness of this. Only using Cabal? That's cool too. Cabal's come a long way. You know, I use it a little bit here and there on little tiny mini projects and throwaway projects and just kind of stuff just to see what's going on, you know. It's got a lot of similar feature set to Stack. Stack still has a bunch of extra stuff on top, but yeah, I mean, that was kind of an interesting history. When I first started really digging into Haskell, it was kind of like my second time around learning it. And it's probably like 2017, 2018. And at the time, like, there was kind of like there was some beef going down between the two camps. And it was kind of interesting time to be a beginner because you were like, well, which build tool should I use? And everyone was shouting their answers. You're like, listen, stop fighting, Mom and Dad. But I just went with Stack because I was reading Haskell from First Principles, I think, and it recommended it. It was like, just use this. I was like, okay. It was very confusing. A very confusing time. And it's still sort of confusing, I guess. But the competition kind of, you know, Cabal really pulled up the bootstraps and made some cool stuff and some better stuff. I made the tool a whole lot better, so that's good. Okay, so we're back to building. The code works. The game works. I'm going to make a commit here on this branch. You know, I think we're going to be roughly evenish. Let's see, minus 71, plus 73. We still haven't done the refactor we want to do yet. Oh, actually, yeah, we're going to be able to beat it. We got to get rid of this hunk here. We don't want that debug.trace sneaking in. Okay. So, and this change applied, we pull the player, we add a ship type. And we refactor the kind of like global game state player ship variables into it. so that now we can do the refactor we want, which was to add an instance to the ship with our position and velocity classes. So there's the ship. It already has instance and has velocity. So now we can use our generic get our update position function. You tried to learn Nix and see how it can be useful in that space, but I could never understand the syntax. Yeah. I have the same problem where every time I go to try learning Nix, it gets confusing really quick. There's a cool new site that just came out this week, I think. 0tonix.com. And I've went through this kind of the beginning bits of it, and it's laid out pretty nicely compared to other Nix tutorials I've seen. Oh, good. Yeah. So I think one of the core problems they have with this project is that Nix isn't just a thing. It's a whole umbrella of things, and they're all called Nix. Which Go has the same problem. Golang, the Go language, a similar problem in that it's hard to Google. Right? It's hard to Google about these things. All right, so it kind of lays it out right here. Like, these are the 4 main things in the Nix ecosystem that you have to know. All right, there's the build tool, there's the package repository, there's a whole Linux distribution, there's a language, there's actually like a 5th thing off to the side called the Nix store, and all these sorts of things. And that's very frustrating when you're trying to learn this stuff. It has a lot of benefits. If you ever have kind of like a build problem and you mention this in Haskell channels, I'm sure someone will pipe up and say, have you tried Nix? Nix has its own Rust evangelists. They're everywhere. And they will always tell you should be using Nix. But if you get into this, it's pretty cool. But it'll take over your entire project. You had build tools before, but you're going to be configuring them in Nix and getting Nix to build them for you. And you might want that because then you get all the benefits that come with that, but it takes over everything. So you have to learn the whole kit and caboodle in order to get really good mileage out of it. So I'm glad this exists because I'm going to finally dig into it a little bit more. I only just use Nix. I don't really know it. But one day I'm going to go down the path. And then I will be one of those annoying Nix zealots. I will join in the warm fuzzies of the Nixness. The hidden secret 6th area of Nix, the fuzzies. Yes. Well, we'll have to be, because if you want to use Nix, you have to use the whole thing. Right? You can't just use part of it. Okay, so let's finish up this refactor and call it a night. So the next bit we can do to the update now is instead of updating the position independently as a separate variable, we can use our more generic function to do the update calculation for our ship. Let's be a little bit careful and make sure we do this right. But I think we should be able to do this independently. Because position only depends on the position. The next position only depends on the last frame's position, the last frame's velocity, and the delta, nothing else. All right, so when we pass position in here, we can get rid of this Raptor stuff. Oh, we weren't testing with the wrap of the dynamic ship size thing, so this might This might break that a little bit. Hopefully it'll be fine. Because we've hard-coded the size and the update thing. Anyways. So I think we should be able to do... We should be able to get rid of this position. And then we can do, like... Yeah. Update position of game state player ship. And the delta. And then we can update the ship where the rest of the stuff happens. And we can ignore ship position. I think that's equivalent. Okay, let's name shadow binding stuff. Where's that happening? Oh, in this line here, probably. It made me do it. Okay. Yeah. Let's accept that. Okay. Everything works still. We're good. Super duper. Cool. So, like, when you're refactoring stuff, you know, go one step at a time. Sometimes you got to slow things down, go line by line. Make that breaking change and get back to compiling right as quick as you can. And sometimes you have to do it in steps, right? So you make the smallest possible change so that that gap from green to red to green is as small as possible. And just kind of break things down. So like change one part of an equation and just do substitution until things start working again. And that kind of stuff. So that's one strategy for refactoring with Haskell and why it's pretty awesome. Exactly. Swarm Collective gets it. The power of a great type system. It's overwhelming sometimes. It makes me giddy. Cool. So yeah, we should be able to, let's just kind of quickly review this refactoring itself and kind of what we did to the game. Now, not talk about refactoring in general. So we kind of added these two type classes, has, position, and velocity, which are a little weak. They're not doing a whole lot, but they give us the ability to kind of abstract over any type to have this generic getter and setter for them. There are other approaches to doing this that maybe even be less boilerplatey, but this is a fairly straightforward class. Once we have that, we can implement it for any object in our game system where we want to be able to do physics calculations based on these positions and velocities. And we do that with our kind of generic update position function here. Right, so we pass in those constraints, has, position, and velocity, and now for anything that implements those two classes, we can update its position with that single formula. So this formula used to be kind of copied and pasted in 3 different places. Now it's in one place, and we're going to update everything uniformly. We could expand on this now even further, pulling out the other kind of physical elements that we need to do other calculations like rotations and whatnot. Yeah, so we've done that with bullets and asteroids as well already. So now the update bullet function, bullet physics function, is just using update position, F mapping all over the deck of bullets. Same with the update asteroid, right? We're also rotating the asteroid in its update, so it does that as well, but we can just use the update position to do it. So we'll be able to pull more of these out and continue this refactoring of the physics system. I think along this path sets a pretty good foundation for doing that. So I'm going to push up this code, finish off this last commit, and when we apply this change, we're going to change the player ship to use new physics position. Yeah. Man. Yeah, I'm not gonna squash down those commits. I think those are good. So you can get this code. I'm gonna merge this into master, or pull this into master. And we'll pull it in. Wait, physics refactor, yeah. Oh, how do I do that? Yeah, there we go. So pull those commits on a master. So you can get this code on my GitHub. It's at github.com. I'm Agent Ultra, by the way, if you're tuning in for the first time and checking things out. So I'm Agent Ultra in lots of places, including GitHub. That's me. And this is Asteroids. So you can check the code out here if you like. Start, like it, whatever. Mess around with it. And see if you can build it. Make it work. You need SDL2, of course, and all that stuff. I haven't set up build instructions and all that, so we'll have to get to that. Might be one of those things that Nix is really good for. So we can get a common shared development environment with all the dependencies in the right place and all that kind of stuff. Maybe Stack could do that too. I'm not sure. But anyways, if you're going to build it yourself, you're going to have to get this stuff. So ranting, that's where you get the code. You can follow me on types.pl or on the Fediverse at types.pl, Agent Ultra. That's me as well. And I don't know how to type the link there, but there you go. Of course, you can always, follow me here. You'll get notifications when I go online. Sometimes I do surprise streams, but usually I do these on Tuesday nights at 10 after 8 in the Eastern time zone. So tune in next week and we'll see you then. That'll be awesome. If you're watching on YouTube, you know what to do there, of course, and have a great night. May your monads always be free, and may your types always check. Take it easy.